Okay, stats, we've made it to the final day. This is your last lesson for stats with me. Um, there's a couple things that you will need for this video. So the first one is this normal distribution sheet, which I have attached to Google Classroom to this assignment. So this is what it looks like. I also have on there the empirical rule sheet. So you will need that copy, and then you'll need your positive and negative z-score table, this guy. Okay. Um, so so have kind of all three of those things handy. This first one that we're going to start with, this is a project that I usually do with my algebra kids, collecting data and stuff, but I've kind of altered this assignment and kind of advanced it a little bit for some review for you guys. So this data is data that we did last year, that we collected last year because we didn't have class this year. So like you'll notice that the seniors had last year's senior class. You guys' class will be in the juniors, and we only took 5 boys and 5 girls from each class. So some of you guys are on this list. I guess Katrina, Michaela, you're the only 2 girls that are in this list. And Jace, I guess, is in the boys list too. So there's 3 of you that I guess made the cut. You must have been available that day that we were taking data. So this stuff is from last year, and we're gonna put this information onto a bell curve, like down below, and do some data crunching stuff with it. So the first thing that we need to do in order to put this on a bell curve, this middle number here, we need to figure out what our numbers are. Okay, so normally your X bar is this middle number in here. And then this is +1 standard deviation. This is +2 standard deviations, +3, -1, -2, -3. That's kind of what your bell curve will look like, okay? So we need to figure out what our average is, or what our X bar is, and what our standard deviation is. So I have, and at the top of the sheet, it has the link to the spreadsheet. I'm just going to go ahead and open that up, and we'll crunch some numbers on there real quick. So I have it here, okay? So this is exactly what you're seeing on your sheet. I've just copy pasted it over, and then we went ahead and in the algebra class we do boys, we do girls, and then we do all students. For you guys, I'm just going to have you do all students because we're going to do a little bit different stuff with it. So what I did was I took all of the students, lined them all up, and then we need to find the average and the standard deviation, okay? So I just do equals AV, average. I want average, and I'm going to select all of these numbers going all the way down, and it's going to give me the average height. Okay, now each one of these is in inches, so all of the height data is rounded to the nearest quarter of an inch, but like this 61.25, that would be 5 foot 1¼ inches, is how that kind of works out. So all of these are rounded to the nearest quarter of an inch, but they're all in inches, not feet and inches. Okay, standard deviation, I'm going to do that. Select all of my stuff. And there's my standard deviation. Okay, so let's go back to the sheet and let's transfer that over here, and then I can resume again. So the average height of all students in the survey was, this guy says 66.38. Let's go ahead and do that. 66.38 inches. Okay, so that is 5 foot 6.38 inches is basically what that is. If you need to think about that in terms of what that actually is. Standard deviation was 3.76 inches. Okay, so now let's fill out what our bell curve looks like. So we're going to have to, I'm just going to write this as 66.38 in the middle. Okay, because we're going to leave it as inches and not feet and inches. So there he is, okay, and then what I'm going to do is I'm going to add our standard deviation 3 times, so 66.38 plus 3.76. There he's added once, so 70.14, okay, plus 3.76, 3.76 again is 73.9, plus 3.76 again is 77.66. Okay, so that's what he will look like. Then down below, if I start with 66.38, and I subtract 3.76, 62.62 minus 3.76, this is the second time, 58.86, and minus a third time, and 55.1. Okay. All right, so there I have this, my bell curve set up. Basically what's happening here is this middle part, 50% of all students should be taller than 66.38, and 50% of all students should be shorter than 66.38, okay? Then from there, we can follow the empirical rule, which tells me a little bit more information. So like this would be my +1 standard deviation, this would be -1. So if you remember from when we did this in class, those two cutoff points, there is 68% of students that should live between this marking and this marking. So if I kind of refer to ours, let's see, I can say that about 68% of all of the students in the high school should be between 62 inches and 70 inches, approximately, or 63 inches and 70 inches. Okay, so that's kind of how that works. So we're going to use this graph, and I actually put it off another sheet of paper so that you can have this up here. And we're going to answer some questions here. So find the range. So this is number 1 on the back side. I'm just going to leave my bell curve up here so I have it all kind of together. Find the range of all students that represent the middle 68%. Okay, so empirical rule sheet, middle 68% is between -1 and +1. Okay, -1, +1, the range will be from 62.62 inches to 70.14 inches. That's the range. Okay, so the middle 68% will be from that height to that height. Okay, now the range of all students that represents the middle 97 or 95%. 95% is within 2 standard deviations. So almost all of my students are going to be within 2 standard deviations. Okay, and according to this data, those two heights are 58.86 and 73.9. So I can expect that about 95% of my students are between 58.86 inches and 73.9 inches. Okay, and the last one is 99.7%. Okay, and 99.7% is the last one that it gives me, which is between -3 and +3. Now, that's not entirely 100% because there's still like 0.3%. There's still like maybe one student that lives either outside of here or outside of here. You know, maybe they're shorter than this point or taller than this point. So we'll talk about that in a second. But +3, -3, that is 55.1 inches to 77.66 inches. Okay, 6 foot exactly is 72 inches. So this would be like 6'5" inches. And I don't think anybody in our high school, or according to this data, was taller than that. Anybody shorter than 55? There's a couple people that were close. Nope, I don't think so. According to the data that we have, I don't think anybody lives actually outside of that region. So ours would be 100%. But you know, we might in the high school. I bet you we have some 7th graders. Some 7th graders that are lower than 55.1, maybe. I don't know. That's pushing it. Okay, so, you know, there's kind of how that works. Okay, find the range of all students that represents the top 2.5%. Okay, so what we can do here is on the empirical rule, or on this sheet, the top 2.5%, this is 2.4% that lives between the +2 and the +3. And 0.1% will live beyond that. Okay, so the top 2.5% would be those two categories together. So basically, that's everything from here and beyond, right? That's going to be everything from the +2 and beyond. So anyone taller than 73.9, because that's +2 and beyond. So this is 2.5% right there. So anybody taller than 73.9. Okay, the bottom 16%. Okay, 16%. If I add 0.1, 2.4, and 13.5 together, This category represents the bottom 16%, so anything from here and beyond this way. And that's from the -1 on down. Okay, so that's anybody shorter than this marking. Okay, so -1 marking is 62.62. So anyone that is shorter than 62.62, that represents the bottom 16%. Okay, that would be me. 62.62 is about 5'3", or a little less than 5'3". I'm less than 5'3", so I am technically in the bottom 16% of this. Okay, now this is where it gets a little bit different, and this is where we can't use the empirical rule. Okay, so this is where the stats stuff comes into play. All right, find the range of all students that represents the top 25%. Okay, so this is where we're going to start to use our positive negative z-score table. Top 25%. So what I'm saying here is that top 25% means that 25% of all people live here, which means 75% are below. So I want to know what this person is right here in order to figure out what that height is. Okay, find the range of all students, top 25%. Okay, so what I can do is I know that I'm going to be on the positive side table. I need to be on the positive because 25%, he's on the right side of the table, basically. Positive z-score. Okay, so the table, or this thing, will only read from here on back. Okay, so what I need to look up is that 75%. Okay, and it will look up as 0.7500. So in the table, I need to find the z-score that's closest to 0.7500. So I'm going to look on here. I have 0.7486 and 0.7517. He's going to be closer to 7486 because I think that's only 14, or 0.0014 away, and this is 0.0017 away. So we're going to go with this guy. And so he has a z-score of 0.67. 0.67. That's how I read this. 0.6 and 7. Okay. So I'm going to put z is equal to 0.67. Okay. Now there's a couple more things that I have to do. I have to transfer that to a height. Okay. So 0.67 is going to be a z-score that's about right here. Right. This would be the z-score of 0. This is a z-score of 1, a z-score of 2. That's what these numbers do down here for me. Okay. So 0.67 is going to be that guy right there, and I need to figure out what height that is. So it's somewhere between 66 and 70 inches, something like that, right? But how do I figure out what that is exactly? So z is equal to x minus x bar divided by my standard deviation, okay? So I'm trying to figure out what that x is, all right? So I know what z is, and then I can just rewrite my formula and solve for x, okay? X bar is that 66.38. divided by my standard deviation, 3.76. Okay, so I'm going to take this equation right here and I'm going to unwind it and solve for x. So how tall does that person have to be? Okay, so the first thing I do is multiply by 3.76. So I'm going to do that now. 0.67 times 3.76. So if I multiply the 3.76 over multiply by 3.76, I will get 2.52 equals x minus 66.38, and then I can add that 66.38 to the other side. Okay, if you don't need to write out all of these steps, you don't necessarily have to, that's fine. So add 66.38. So 68.9. So find the range of all students that represents the top 25%. This marking right here is 68.9. So we would say anybody taller than 68.9 is going to represent the top 25%. So you're in the tallest fourth of all students, basically, is what that's saying. Okay. Now, number 7, same thing, but now they want the bottom 40%. Okay, so I'm going to draw my bell curve here again, but now we're doing bottom 40%. Okay, 40% is going to be here. 40%, that means 60% is here, and I need to figure out what this cutoff marking is. Okay, my table always reads from here back, so I'm going to be looking at 0.4000. and I need to figure out what that z-score is, okay? Positive table versus negative table. I'm on the left side of the graph, so I'm going to be looking at the negative z-score table, and I want to find the number in here, the percentage in here that's closest to 0.4000. So he's toward the bottom. This one is awfully darn close. 0.4013, I think, is as close as we're going to get. Oop. Right there, 0.4013. So if I read them all the way over, that's going to be negative 0.25. Negative 0.25, okay? So my z value that I looked up, negative 0.25, that's what he is, okay? So again, we're looking for a number. If I bring my bell curve down, let's pull him all the way down here, okay? Negative 0.25 is going to be a number about right here. So really close to 66.38, but not quite as low as 62.62, okay? So I'm going to do the same thing as I did up here. I need to figure out what that height is. So x minus 66.38 divided by 3.76. And then I'm going to multiply the 3.76 over and add the 66.38. Okay, so I'm going to do that all without writing it out. Negative 0.25, okay, times 3.76. Okay, and I get that number. And then I'm going to add 66.38 to that. Okay, and the answer I get is 65.44. So just a little bit less than 66.38, like we said. So 65.44. Okay, so let's talk about that range here. If I want the shortest or the bottom 40%, it's going to be anybody that is shorter than 65.44. Okay, so there's what he will look like. All right, okay. Now these last ones aren't quite as difficult as that. We're still using that formula, so z equals x minus x bar divided by the standard deviation. Sometimes I'll write it like that instead of s, it doesn't really matter. What percent of students are shorter than 5'6" or 66 inches? And then what percent are taller? Okay, so let's do shorter is however many percent, and taller is however many percent. Okay, so we need to first take 66% and convert it to a z-score. Okay, so 66% is the number that I'm looking at, minus 66.38 divided by the standard deviation, 3.76. We need to figure out what that is as a z-score. Okay, now 66 exactly is just going to be right under 66.38. Okay, so he's going to be negative still, a negative z-score, so negative 0 point something, really small. 66 minus 66.38 is going to be negative 0.38. That's what he will be. Okay, did I do that? Oh, no, wait. I need to divide by 3.76. There we go. Negative 0.10 is what he is. Okay, that's better. All right, now from that point, all I need to do is just look him up on the table, but I'm going to look him up in the correct order. He's on the negative table because he's negative. And so I look up negative 0.10. 0.10 all the way down here at the bottom. Negative 0.10 is this column, so 46.02%. Okay, now 46.02% is going to be from here on, from that point on back. So 46.02% are going to be shorter than 66 inches. Taller than 66 inches would be the opposite of that. So 100 minus 46.02 is going to give me 53.98% of students are going to be taller than that. Okay. All right. Now 72 inches. We're doing 6 foot now. Okay. What percent of students are shorter than 6 foot, and what percent of students are taller than 6 foot? So we need to convert that to a z-score. 72 inches minus 66.38, just like we did up here, divided by 3.76. Okay, and that's going to give me a positive z-score, a really big one. 72 minus 66.38 divided by 3.76 has a z-score of 1.49. Okay, so to figure out, so we're going to be on the positive table now. Okay, positive table. 1.49 is going to be here all the way over here. 93.19. Okay, 93.19. So on a bell curve, okay, he's going to be 72 inches is all the way over here. 72 inches. 93.19% is going to be that direction. This direction would be like 6.81%. Okay, if I subtract that. So shorter than 72 inches, the shorter percentage will be 93.19, and taller will be 6.81. So there's only about 7% of students that are going to be taller than 72 inches. I think that includes like J.C. Himmelberg maybe, and Tanner Lumpke. If you look on that list from the front side, yep, both of those boys are going to be taller than 72 inches or 6 foot. So they would be in this category, the taller than 72 inches category. Okay, last couple ones. What is the z-score of your height? So I'm going to do my height. My height is 5'2", so I have 62 inches. So 62 minus 66.38 divided by 3.76. My z-score is going to be a negative number. So 62 minus 66.38. I'm going to have you do this on here, but with your height. Okay. So I have negative 1.16, and then percent of students that are shorter than me. There's not going to be a lot of students that are shorter than me. What percent of students are taller than me? So I look up the negative 1.16 on the negative side, okay, because mine's negative, yours might be positive. 1.16. 1.16. So I have 12.3%. Woo! 12.3% of all students are shorter than me. So that means that 87.7% of all students are taller than me, according to this data. Okay, so that was just kind of a run through of normal distributions and z-scores and all that good stuff. This is your last project, last video. Congratulations, you've made it.